Hello, welcome back. Here's Marcel, and now we're gonna solve in this video the first Rosalind problem entitled Counting DNA Nucleotides. As you can see, this problem has been solved by more than 75,000 users. Okay, so first let's take a quick look at the layout of the platform. In this problem, we have a brief introduction to molecular biology, so it's really interesting for you guys to read and to remind some concepts. This type of text not happen in most of the most problems. Okay, so it's really interesting. And here we have the problem. So the problem we're going to use the concept of string, which is basically a set of letters that we can think as some text that we use in the real life. Okay. So in this problem, we're going to receive a DNA string like this, and we have to count how many times the four nucleotide code happens. 8 for adenine, C for cytosine, G for guanine, and T for thymine. So we're going to receive a DNA string entitled S with length at most 1,000 nucleotides, and we're going to return the four integers counting the respective number of times that the symbols occurs. Okay, and we have to be separated by space, so this is really important. So this is an example and of data set we're going to receive, and this is an example of output we have to return. So looks easy, right? So there's a catch. We have a time limit of 5 minutes. So once we click in download dataset, the timer starts to count. And of course, there's no problem to make a mistake. There's no problem to get a timeout. In fact, I have some timeouts here, but it can be a real boring. You download a data set and you get a negative result. And of course, if you download a data set and you have a timeout, you can check if your answer is good. Okay, so let's first model our problem. Okay, so we're gonna get here. Let's come here, DNA tools. Okay. Let's remind that we're going to use the DNA tools, so the U tools here to model our problem, okay, to develop the function that we're going to need, and we're going to use the scripts to run it, okay. So let's take my notes here. So this is a DNA string, right? We can see it's remind what we see in textbook, but there's a catch when we're talking about bioinformatics. We have to do some kinds of tests to run. So one task that's important is to check if this is, let's block this again. Okay. If this is a valid DNA string. So let's see, valid date DNA string. Oops, DNA string. So you're going to check if the DNA string that is a DNA string. So the argument I will call DNA string and it's a string. Okay. So and the result should be a boolean. So first, let's check if the what user gonna pass as DNA string argument is really a string. So we're gonna use is instance and check DNA string is a string. So if not a string, the function should return a false. Oops, false. Okay. So the second test, it's really could be really ridiculous, but we should test if the user pass any value to the DNA string. So if not, it should return false. Okay. So now we're gonna need to check if the string that the user pass is valid. So we need to check if the string uh, contains characters that represents the base of the DNA. Okay, so we're gonna do create this set here. Okay, as you can see, it doesn't need to be alphabetically. And now we're going to check if all of the nucleotides in the DNA strings are valid nucleotides. So to do that, we're going to say nucleotide and valid nucleotide for nucleotide in DNA string, but dot upper. Because sometimes bioinformatics we receive strings in uppercase, sometimes in lowercase, so we're going to use the upper here to avoid any problem. So once that we perform a check, now we can be able to define the counting or count nucleotides function, which is DNA, which has argument which is the DNA string and should return a string, right? Because we want to return a string containing the count of each nucleotide. So first, let's use this function here to test. I'm sorry, if not, uh, DNA string should return. I'm sorry, should raise a value error. So error, the sequence is, we can be dramatic here, is not a valid DNA string. I'm just joking, please don't do this with your users, okay? So now we can use, I will copy it from my notes so we can be faster. Now we're going to use this DNA string dot count to count the number of A's, the number of C's, the numbers of G's and T's. Okay, and I'm going to define it as an A and C and G and T. So finally, what we can do is return print. We're going to use the print function and we're going to use the f string. So f string, we can use curly bracket to pass a variable and to print the value of a variable. So NA, NC, space, NG, and finally NT. Okay, so that's interesting. We have the functions right now. Okay, looks okay. I think it's okay. So now let's test. So we're going to create a seq parameter here. So let's run it. Okay. So count nucleotides seq. And 20, 12, 17, 21. Oh, let's take a look. And oh, voila, it's the correct answer. So we have now we have the functions to solve. We have the functions necessary to solve. Okay, so we will clean it for us, and now we're going to create the code to solve. Okay, so we're going to use import system. I'm going to import OS. I'm going to import from source utus DNA tools source utus DNA tool. I'm going to import count nucleotides, which is the function that really do the job here. Okay, so now what we're going to do is to append the path to the data. Okay, so copy here to be faster. and it will be this code syspath_pen that path, the absolute path, join the name of the file. Okay, so this is a little catchy, right? So now I'm going to define the so function, which doesn't need to receive any any arguments. So here we're going to do with open, and here we're going to use this R string, and we're going to pass the R. Here I'm going to put the path. Okay, the path will be for files like this, txt files like this. So as f. So here we're going to do seek receive f read stripe. We're going to stripe the lines. Okay. So once we have it, we're going to count nucleotides in the seq. Okay. So finally, if let's put it run or finally run name. My mistake here. If name equal main, run so. Okay, this looks nice. So what we're gonna do here is copy this relative path, and I'm gonna put this 5 because now we are able to get here and download dataset. Okay, I will put it in the R directory. Okay, here. So as you can see, here is our file, Rosalind DNA 5. It's a huge DNA string, right? So we have it here. Oops, 5, okay. Let's come back to PowerShell and Python and Python and let's see my note here just to not make a mistake. Python and source script DNA. Cross your fingers. Okay, we have the result here. So let's go back to Rosalind and copy. Now let's submit. And we made it. Okay, thank you guys. That's nice. So we finish and we got the correct result. So, okay, that's a really interesting thing. So now I'm going to give here before we finish. Come here and say problems. So and DNA. Oops. DNA. And here we can get the URL. Okay. So now we have here we're gonna can update our README for our GitHub repo. Okay. So that's it. We finished the first Rosen problem. Looks nice, right? Um,